look at this example in in a projectile. This is an example of projected objects. So let's read the question here and then try to solve it. Supposing a projectile is launched vertically upward from a platform whose height is h from the ground. When the projectile is returning to the ground and at a distance h below the platform, its velocity is twice its value when the projectile was at the same distance above the platform. Calculate the maximum height reached by the projectile. First, let us interpret the question and then see how we can calculate the maximum height reached. We'll use a two-dimensional Cartesian coordinates where the horizontal is x and the vertical axis is y. Assuming the platform is somewhere here, let's label the point. Can use anything. Let's say it is P. So the projectile is launched from this point vertically upward. Let us represent that by having the object here representing the projectile, then it's launched upward, then it will go up and then reach a maximum height and then return on a motion back to the ground. We are told that at a distance h after the launch at a distance h, we have a velocity. Let's label it v1. That is an intermediate final velocity because that is not the end of the motion. Then on its way back to the ground, also a reference point was mentioned in the question at the same distance from the platform. Say the distance is here and it's also h from the platform, so it means from here to this point is h. The velocity there also is another or say final velocity as mentioned in the question, v2. The question now is, how do we obtain the maximum height reached? This is the maximum height. So the height from the ground is h. Let's call it h. So from here down here, what is h? That is the question. How do we calculate that? We are aware that there are equations of motion that can be used in this regard. As it will be applicable to this problem, we know that one of them is say at point or height h, we know that final velocity generally v square equals to u square, which is the initial velocity. The initial velocity is the velocity with which it is launched down here, and plus 2 multiplied by the acceleration, then multiplied by distance. This distance will now represent this h, that is the height. So let us adapt it to the problem. That means at height h, we have v1 squared equals to u square plus 2. A in this case is acceleration due to gravity because the object is launched vertically upward. And for the acceleration due to gravity, have g positive while the object is coming down. It's positive while the object is coming down. And so we have, since the object is launched vertically upward in this regard, this plus is minus, that is minus g multiplied by the distance h. So we call this one equation 1. And then again, let's look at what happens at the second reference point where we have v2. We also use the same formula. We'll have v2 squared equals to initial velocity still u square, then plus yes, because it is coming down here, so this is plus now while the first is negative, 2 multiplied by acceleration due to gravity, then also h. Yes, we call this equation 2. And at point where we have v2, we are told that this v2 is equals to twice v1. Yes, so we can also write that also comma have v2 equals to 2v1. So that is another equation. So 3. We can use this v2 this equation 3 to modify equation 2, or we say putting equation 3 in 2, we'll have 2v1 square equals u square plus 2 gh, which implies that we have 4v1 squared equals u square plus 2gh. We can call this one equation 4. Don't forget that what we are looking for is h, the maximum height reached by the projectile. So to get that, we have we need to solve equation 1 and 4 simultaneously. So to start that, let us multiply equation 1 by 4 so that we can eliminate v1. What we're actually looking for here is something that gives us the impression of height. And so we multiplying 1 by 4, comma, we have 4v1 square equals 4u square minus 8gh. Call it maybe 5. Then we have this is 5. So we subtract 4 from 5 and subtract 4 from 5. So that implies that this minus this will be 0 equals to 4u squared minus this will give us 3u squared. Then this is minus, that's minus 10gh. So we can resolve this to get u squared equal to 10gh divided by 3. We prefer to make u squared the sort of formula because of what we need just after this. What we need is the initial velocity that will help us to resolve what the maximum height is, because maximum height in projectile is given in terms of the initial velocity. Generally for a projectile, projectile, comma, we can maximum height is given by h equals to u squared over 2g, then multiply by sine alpha. But what is this? What is this alpha? We can illustrate it here by giving a basic projectile illustration. This is x-axis, this is y-axis. Then we have the projectile motion represented by its trajectory this way, where we have the initial velocity vector u, which is making an angle alpha with the horizontal. So if before then we have range r, which is the horizontal distance covered by the projectile, and of course this is h, from here to here, the maximum height reached. And if you look now at our question, you will find out that the motion is vertically upward. So this initial velocity is vertically upward, making this alpha to be 90 degrees for the problem we are solving here. Therefore, you can write alpha for our problem to be 90 degrees. In that regard, let's call this equation equation 6, and this one equation 7. So we can say substitute both alpha and u square in equation 7. So what do we get? We have h now equals to u square. What is u square? We use equation 6. U square is 10gh divided by 3, and that is also divided by 2g, then multiplying everything by sine of alpha, which is sine 90 degrees. So h is equal to 10 gh divided by 3. So now multiply by 2g, then multiply by 1. Sine 90 is 1. You can cancel g here, then divide by 2. Here 1, here 5, leaving us h equals to 5 h divided by 3g. So this h here is the maximum height reached by the projectile. Let me mention generally that for projectile we have the where y is the vertical distance. We have that y equals to x. X is the horizontal distance multiplied by tan of the angle alpha here, then minus half multiplied by gx squared divided by u squared cos square alpha. And again, we can also talk about the time of flight of the projectile, which is equals to 2u sine alpha divided by g. So finally, the range r, which is the horizontal distance covered by the projectile, is equal to u square sine 2 alpha then divided by g. Thank you.